Okay, this looks like an interesting problem. This is problem 8 from your homework, your module 5 homework. So there's a question, are sons taller than their fathers? So we interview 13 fathers with adult male children, and we record the height of both the father and the son. And we're given the data in a data table, which we can open up in StatCrunch in a moment. But before we begin, we have to check the conditions which must be met by the sample for this test, check all that apply. So take a moment to read. So I checked the sampling method results in a dependent sample. This is different than what we did earlier, where we needed an independent sample, right? Because one father and one child, right? Those would be, it's the same family, right? You wouldn't check a father from an NBA basketball team and then the son from like a bowling team, right? You'd want the father and son to be basically matched. The differences are normally distributed, or the sample size is large and the sample size is no more than 5% of the population size. All right, so now we have to come up with the hypothesis test. So the null hypothesis would be that there is no difference, right? The difference would be 0. And let's see, if xi, I got to see who xi and yi are. So I click this table to open up my data. So xi is the father height and the yi is the son. So if I did father height minus son, if the son is taller, the difference would be negative, which means the difference would be less than 0. Right? Again, let's review that. Right? If we're looking at xi minus yi, right, the height of the father. If the height of the father is smaller than the height of the son, that means the son is taller. If we subtract the height of a father who's shorter than the son, you'd get a negative number. So the difference would be less than 0. That's how you get your negative number. I check answer. Yeah, it worked. Good. Now it says calculate the test statistic. Okay, so let's open this in StatCrunch. I click open in StatCrunch, and a couple of things I want to do. First, I want to do my xi minus yi. So if you remember in the past, we click data, compute, expression, and I want to build. Let's make this a little bigger so you can see. Build. We want to do the father minus the son, and we press OK. And this is the height of the father minus the height of the son. And now from here, we can calculate the test statistic. All right, so if I press stat, t-stats, one sample with data, and we're going to use this column here, and we'll do a hypothesis test, right? The difference was equal to 0. The difference would be less than 0. Press compute. Here is my t-stat, right? So I enter that here. And remember, we have to round 2 decimal places. So this is 1, 2. So it looks like we have to bump this up to 1. Okay, I check my answer. Good job. Next, it says calculate the p-value. So we've done that, right? Our p-value in this case was the 0.496, right? So I'll enter my 0.496. That's 3 decimal places. I check answer. Looks good. And then it says, okay, so because my p-value, what was the level of significance? It was 5, right? 0.05. My p-value is greater. So we're going to do not reject, right? If your p-value is greater than your level of significance, you do not reject because the p-value is greater. Therefore, there is not enough evidence to conclude that sons are taller than their fathers, right? Because if we're not going to reject HO says there is no difference, right? HO, the null hypothesis, says there is no difference. So we don't reject it because the p-value is greater than the level of significance. So that means there's not enough evidence to accept the alternative hypothesis, which was that sons are taller than their fathers. Check answer. Great job. Let's move on to the next question, right? Question number 9. So you have a manufacturer of hardness testing equipment, and it looks like they use a steel ball and denter to penetrate metal that's being tested. And I'm going to pause and shut up and let you read the rest of this. So we're asked to construct the confidence interval at the 95% level to judge whether the two indenters result in different measurements. So we could do a hypothesis test, but they're asking us to do a confidence interval, so that's fine. We click the table. Here's our data. Now you got to be careful here. I made a mistake a few times. Notice it says the differences are diamond minus steel. So when I open this up in StatCrunch, we have to make sure we do diamond minus steel. So diamond is the second column. So I press data, compute, expression, and let's expand this a little bit. Build, diamond minus steel. Okay, compute. There's my diamond minus my steel. And now let's create the confidence interval. Okay, so we do stat, t-stats, one sample with data, diamond minus steel. Here's my confidence interval. We were at the 95% level. So my lower bound is found here. And it says round to the nearest tenth. So I can make this a 0.2. And then for the upper bound, we have this 2.947 and change, and we're going to round that to 2.9. Okay, and I check my answer. Well done. So remember, the null hypothesis would be that there's no difference, meaning there'd be the difference would be 0. But because my interval doesn't include 0, we cannot accept the null hypothesis. So we'd have to reject the null and accept the alternative. So in this case, there is sufficient evidence to conclude that there is a difference in hardness readings, right? Again, if 0, like let's say this went from negative 0.2 to positive 2.9, well, 0's in that interval, so we might have to accept that there is no difference, meaning the difference would be 0. But since 0 is not in our interval, we reject what would be considered the null hypothesis and accept the alternative. And in this case, that would be that the two indenters produce different hardness readings. That's questions 8 and 9. I hope you enjoyed. Thank you for watching.